Hello everyone, my name is Nikita. I am from VC branch. My subject is Signals and Systems and my topic is Linear and Nonlinear Discrete Time Systems. What is system? In a system, in signal and system, a system can be defined in a number of ways as such as a system is defined as a physical device that can produce and multiple an output or response for the given input. A system may also be defined as an entity which works on an input signal and transforms into an output signal. A system can also be defined as a set of elements which can connect together as generated an output signal corresponding to an input signal. Generally, a system is represented by a block of diagram as shown in figure 1. Here, the arrow entering the box denotes the input signal or excitation of R of t, and the arrow leaving the box denotes the output signal or response C of t. The relationship between the input signal R of t and the output signal C of t of a signal is given as C of t is equals to capital T into X of t. Nonlinear systems are inherently different to test and to interrupt the result correctly. Great care must be taken to avoid ideas how the system is likely to respond. For often, these would influence the type of test being run and the processing techniques employed. Time must be given for complex responses to develop a wide range of different forces frequently, and sweep direction must be covered to ensure that all possible input regimes have been explored. Likewise, preconceived ideas about the expected type of response can lead to introduce the inappropriate conditioning of the response signals, thus mass behaviors that may lead to incorrect classification or understanding of the systems. In nonlinear system, the response to a combination of individual signal at the input will not be same as the response to the sum of those same signals. The relationship of the impulse response to the frequency response in linear system is therefore not applicable. The familiar Laplace transform operation S is equals to, and the transform function concept used extensively in linear system cannot be applied. Nonlinear response is dependent on input signal. The response of nonlinear system the response of nonlinear system is dependent on the input signal size and initial condition as well as the system parameters. A stable response for one input signal may be unstable for another. In nonlinear system, phenomena exist that are not present in linear system. Generation of new frequencies, jump, resonance, limit cycles, etc. The following are the examples of such nonlinear phenomena. Jump responses. Jump resonance. The phenomena called jump resonance is observed in certain closed loop system with saturation where the input and output amplitude ratio and phase angles are as a function of frequency exhibit sudden discontinuous. The typical closed loop gain characteristics of a saturation system with a jump resonance are shown in figure. Amplitude ratio theta naught by theta I is plotted as a function of frequency for fixed amplitude theta I. As the frequency is increased from 0, the frequency response follows the curve along points A, B, and C. At point C, a sudden discontinuous jump to D is observed with an incremental increase in frequency. The output or response of the system depends upon the transfer function of the system. The actual structure of the system determines the exact relationship between the input R of t and the output C of t of the system and specify the output for every input. There are various types of systems such as mechanical system, electrical system, electrochemical systems, biochemical systems, etc. All the physical devices such as an electric motor, generator, filter, turbine, etc. are also examples of systems. Depending upon the number of inputs and outputs, the system may be single input and single output system or multi input and multi output systems. Linear system. A system is said to be linear if it obeys the principle of homogeneity and the principle of superposition. Principle of homogeneity. The principle of homogeneity says that a system which generates an output y of t for an input x of t must produce an output ay of t for an input ax of t. Superposition theorem. According to the principle of superposition theorem, a system which gives an output y1 of t and in the input x1 of t and an output y2 of t for an input x2 of t must produce an output is y1 of t plus y2 of t for an input x1 of t plus x2 of t. Therefore, for the continuous time linear system, a y1 of t plus b y2 of t is equals to capital T into a x1 of t plus b x2 of t is equals to a into cap. We can take a as a into multiplying t with both a into a t into x1 of t plus b t into x2 of t. Also for a discrete time linear system, here is a equation, and hence we can say that a system is a linear if the output of the system due to weighted sum of inputs is equal to the weighted sum of outputs. Filter circuits, com- communication channels, etc. are the few examples of linear system. Nonlinear system. A system is said to be a nonlinear system if it does not obey the principle of homogeneity and the principle of superposition. Generally, if the equation describing the system contains square or higher order terms of input and output or product of inputs and outputs and its derivation or a constant, the system will be a nonlinear system. Triangulation of GPS signals is an example of nonlinear system. Here is an example of linear and nonlinear system. Check whether the given systems are linear and nonlinear. They given the question, and here is an example. Considering an input x1 of t which to produce an output y1 of t, then we get the equation 1, and then output x2 of t which to produce an output y2 of t. Now the linear combination of equation 1 and 2 gives a into d square y1 of t by d square dt square plus a3 into t y1 of t plus b into d square y2 of t by dt square plus b3 into t y2 of t, where a y1 of t plus b y2 of t is the weighted sum of outputs and a x1 of t plus b x2 of t is the weighted sum of inputs. Hence, the equation 3 shows the weighted sum of inputs to the given system generates an output that is equal to weighted sum of outputs of each of the individual inputs. Therefore, the given system is a linear system, where a y1 of t plus b y2 of t is the weighted sum of outputs, but a x1 square of t plus b x2 square of t is not the weighted sum of inputs. Here the principle of superposition is not satisfied. Here, therefore, the given system is a nonlinear system. Limit cycle is an oscillation to nonlinear system. The oscillatory behavior, unexplainable in terms of linear theory, is characterized by a constant amplitude and frequency determined by the nonlinear properties of the system. Limit cycles are distinguishable from nonlinear oscillations in that their amplitude of oscillation is independent of initial condition. For instance, if a system has a stable limit cycle, the system will tend to fall into the limit cycle, with the output approaching the amplitude of that limit cycle function. A limit cycle is easily recognized in the phase plane as an isolated closed path. In a nonlinear system, the output of the nonlinear device contains harmonic and subharmonic frequencies of the input signal. For instance, application of two sine waves of different frequencies f1 and f2 to the input will produce components corresponding to the input frequencies f1 and f2. Their sum and differences f1 plus or minus f2. Their higher harmonics mf1 and nf2 are the various combinations of some difference. In a linear system, only the components of input frequencies f1 and f2 will be reflected into the output. Clearly, the frequency response concepts of the linear system must be modified for linear applications. In linear system, a number of phenomena can occur which are impossible to predict from the linear system. Linear theory can predict the instance when the system goes through a change of stability characterized called bifurcation, but it cannot predict what kind of motion flows and whether or not the system is stable in critical situation. Filter characteristics of linear system. For a given linear system, an input signal x of t produces a response signal y of t. Therefore, the system processes the input signal x of t according to the characteristic of system. The spectral density function of the input signal x of t is given by capital X of s is s domain or capital X of omega in frequency domain. Also, the spectral density function of the response signal y of t is given by y of s is s domain and y of omega is frequency domain. Therefore, y of s is equals to h of s into capital X of s, or y of omega is equals to h of omega into x of omega, where h of s and h of s or h of omega is the transfer function of the system. Thus, the system modifies the spectral density function of the input signal. The linear system acts as a filter for the various frequency components. That is, some frequency components are amplified and some frequency components are attenuated. Also, some frequency components may remain unaffected. Similarly, each frequency component suffers a different amount of phase shift in the process of transmission. Hence, the system modifies the spectral density function of the input signal according to its filter characteristics. This modification is performed according to the transfer function h of s or h of omega of the system. The transfer function represents the response of the system for various frequency components. The transfer function h of omega acts as weighted function or spectral shaping function to the different frequency components in the input signal. Therefore, an LTI system acts as a filter. Depending upon the response of system for various frequency components of the input signal, that is, filter characteristics, a given linear system can act as following type of filter. When the LTI system allows the transmission of only low frequency components and block all the high frequency components, then the system is called the low pass filter. When the LTI system allows the transmission of only high frequency components and block all the low frequency components, then the system is called high pass filter. When the system allows the transmission of only particular band of frequency and block all other frequency components, then the system is called band pass filter. When the LTI system rejects only a particular band of frequency and allows all other frequency components, then the system is called a band reflection filter. The band of frequency components which is allowed by the filter is called pass band, and the band of frequency components which is not allowed to pass through the filter is called stop band or refle- reject rejection band. Thank you.